Hello and welcome everybody to the NFDI Talks Monday afternoon. I am Elena and I'm working in the NFDI Association's head office. In our NFDI Talks, every 2 weeks, scientists from different disciplines present exciting topics around research data infrastructure and management. Yeah, and all talks are live streamed and saved on our YouTube channel, so you can look up all the old talks there. And exclusively in Zoom, we invite you to discuss the topic and ask your questions also after the presentation that is not going to be streamed then. In this episode, we will take a closer look into the NFDI consortium NFDI for Inc. and learn more about ROkit. ROkit is intended to serve as a modular, expandable software framework for research data management interlinked with NFDI infrastructure. It can be customized to create domain-specific workflows that respond to the heterogeneity of data and methods of modern research. ROkit is designed to support researchers as early as possible in the data lifecycle with fair data standards and practices in mind. And today's speaker is Andreas Noback, who's working in the field of research data management, daylight simulation, and archaeology at TU Darmstadt. Currently, he is employed at the chair of Fluid Systems, supporting the further development of NFDI for Inc. Here, he is focusing on the application of semantic metadata in the collection and analysis phases of the research data lifecycle. Now, welcome, Andreas.
Yeah, hello, and thank you for the invitation and the introduction. As everything about me and what I want to say today is already mentioned, I just go into the presentation, which will have 2 parts. The first part will be a few slides and regarding the concepts and ideas behind ROkit, and then I will also show its applications that are based on ROkit, which are available today in a short live demo. Okay, I just share my screen. Stop the presentation. I hope it is visible. Yeah. What is ROkit? ROkit is an idea that we had as I was still employed at the University Library in Darmstadt, the ULB, and working for the Fachinformationsdienst Bau Digital. And there we had to integrate a lot of research data from the heterogeneous topics that are used and discussed in the field of building research. And what we find was that we have a lack of research data at the end. And we have this problem that many people produce data, but they don't do it fairly. And it is an extra effort for them to upload this data and then semantic enrich it. So our idea then was, and I think this is not a thing that we come alone with this idea, is that you have to support the people as early as possible in the research data lifecycle to make the data fair. So that publishing at the end is not much more than pressing a button. And so what we see is that we can say that we need 3 different things to make data life cycles in the end fair. The first is infrastructure, which we actually want to provide with the NFDI for Inc., with the NFDI and the other consortia. And this infrastructure clearly should contain some kind of knowledge graph and some kind of storage. But what we also need is tools which are employed in production and analysis of data, And what we also need is data models, probably based on RDF, OVL, or Shackle, which go through the whole life cycle. And these three things we'd like to address with ROkit. As my currently employment in the NFDI for Inc., we can see that we have this idea of archetypes representing different research methodologies and typically data handling problems that these methodology produce. And it's easily visible that this produces a lot of heterogeneous data and needs a lot of tools, and they might be all different, but they should base on the same standard so that they are interchangeable and interlinkable in the sense of linked open data. And I think this is a problem that we all challenge in the different consortia. And as a kind of specialty regarding the built environment, is represented at the moment by at least three consortia. The NFDI for Inc., they're the DFG groups for architecture, civil engineering, and urban planning is located, but also in the NFDI for culture, where, for example, architectural history is addressed, and the NFDI for objects, which are dealing with the archaeological side of buildings. And so all these groups have to come together to do something about buildings. And I think this is not only true for this special matter, but also for other topics that are cross consortia, topics that have to be interested in many fields. And so our tools have all to reflect this reality. And I say we have a SIG that we are starting since a while, which is not officially formed yet, but it's also a tool to communicate this stuff between the consortia. And another thing that tooling and infrastructure should reflect is obviously base for NFDI. And in these are just a few examples that are applied for our case. We use technology services yet, and we will also use the base for NFDI technology service. We want to link our data to knowledge graphs, obviously, and we need some persistent identifiers, and we also have to address the topic of authentication. So we try to integrate these services into the tools, which not yet released, only in parts, but this is an important topic for the future, and this is not only of interest for the infrastructure, but also for tools that our users might use to sort out their data. For example, persistence identifiers are not only relevant in infrastructure, but also in identifying objects, data objects, or other entities in the context of research data management. So these are the things that we want to address. And the concept that is behind this is we want to have interoperable components and applications that build and integrate this NFDI for Inc. This NFDI infrastructure, and we want to make the tools or the components that we produce also reusable, also modular and open source. And we want to use them for both infrastructure and tools. So ROkit, as I mentioned, is based on work that we've done for the FED Bau Digital. And as this project is now out of founding, we found a kind of new home with the NFDI for Inc. And what we provide there is the data ingest service for the NFDI for Inc. which should play a role creating fair digital objects in the second phase. And today it's just what we produced for buildings in this specialty. But nowadays for this we have a kind of a pipeline. We have on the left side the heterogeneous data that can be uploaded or can be harvested. We provide an application profile to that, which is modular and interchangeable, so that it fits different kinds of data sets. And therefore, we rely on the NFDI for a metadata profile service. And we also use authentication that is provided by the DFN that we integrated with a Keycloak server. Our interest in the infrastructure is based on a microsystem, microservice infrastructure based on Kubernetes. And if we upload research data, this automatically triggers processes which, for example, create previews or convert 3D models into web-based ready systems that we can view them there, and we can also extract some metadata from that. When this process is over and the additional metadata is added, we provide a DOI for this data set, which can be published, and our backend infrastructure stores these information in the metadata in a triple store, and everything else comes into a S3 object store, where it is also available on the net. Our platform also supports the generation of archive packages, which can serve for long-term preservation. We also provide in this infrastructure some interfaces, for example, OAI PMH or Sparkle queries are possible, and we want to use this stuff to provide this further. We are actually at the moment engaged in two further further projects. One is called DFG 3D Viewer, which uses this interface to build an interchangeable metadata set and repository infrastructure, which can be used to share 3D models across different applications. This is one example we are engaged in. But we also provide our own index and search infrastructure and our preview infrastructure as well. But this is something that serves a very special purpose, but is based on components that are easily can be shared for other applications. And to foster this, we created the ROkit RDF store, which is a Docker-based development kit that uses our infrastructure to edit and store metadata in a way that applications can be based on that. To go into more detail about that, we have a front end and the backend infrastructure, and all this stuff is based on shackle forms, which allows us to create specific data models, and these shackle shape are used to configure the backend as well as the front end. The backend uses this to configure a Solr index, for example, which automatically generates an index which can be used to search for metadata that is added in this development kit. And the front end has a component that allows to view and edit metadata based on these shackle files and generates forms for that. So you can enter your information. And it also uses these shackle files to create a faceted search based on this metadata. So if I create a field, this field can automatically be used as a search facet that we can which will show in the demo soon. So I now switch to the web browser. 2 seconds. And the first thing I want to show is the NFD for Inc. data ingest service as an example applications for what ROkit is capable. What you see here is the exemplary, also the service itself is a kind of minimal valuable product. We have some test data, but we also have some actual live data. We have some people who wanted to present their information, for example, this 3D model of some historic cards in Köln. And we have some heritage BIM examples that are based on a dissertation, which uses our platform to share it. And what we also have, as we have these infrastructure, we have also a kind of search infrastructure that is harvesting plans, and where we use automatically generated search patterns for this stuff. But what I want to show you is what we can actually do here. As you can see, you have a generated preview for a data set, and you also have a possibility to edit a location for that. And we generate not only previews in the sense of renderings of these 3D models, but we can also interpret, in this case, the IFC file in this data set to automatically generate a ground plan. And we can also view this setting in 3D. It takes a while to load, but here we can see what is inside. And as you can see, also see that we have these the collected metadata of this data set. We have our license information and the UI there, and we can also have a kind of knowledge graph view of this information. The idea behind these data sets is that somebody who is searching for a data set has not only the possibility to search by some words or so on, but also gets a quick view what the data set contains, that he can decide that is really interesting or doesn't fit my needs or is not usable in my research. But what I also want to show you is how we can upload data here. You have to sign in for that. You can use your ROkit ID or the DFN infrastructure for that. Takes a second. So, and that what you can see here is that if you want to upload something, the first thing that you are asked is which kind of metadata set you want to use. And as you can see, these metadata sets are kind of modular. We have some basic metadata set with minimal metadata fields. We also have a metadata set for buildings that allows us to provide a location. But we also have some special, a little bit more specialized metadata set, for example, for an architectural model, which allows us to create more specific information, for example, that not only the building that the model represents has a location, but also the model itself can have a location, for example, in a collection. And also the dimensions of the models and so can be entered there. So I choose the metadata set for a building in this case. And if I upload a file here, go to my desktop. For example, we have here an example, exemplary IFC file. And as you can see, this will be uploaded, and now the backend starts to convert part by part this metadata set. And here it firstly generates the 3D model, but soon it also provides some SVGs that are, I see, are black at the moment, but I think this is my browser that doesn't support this special format. So as you can see, this is automatically generated on the fly. And if this is done, or even earlier, you can go to the metadata field. And as you can see, we have typical metadata set we have to fill in. And we can also add, for example, a location here and open our map view and position it where we want to do that. And we can also, we can use a point, but we can also give this metadata set an area, maybe a footprint of a building if you want to do so. So, and as you can see, this generates a coordinate system, in this case in VTK format. This is standardized by the Geospatial Consortium. And and you have the typical fields that you can do with metadata. And if as you can see, we can use construction material and stuff like that. And when I go back to the beginning, I can reset my data set. And no. Okay, this doesn't work at the moment. I see. Okay. But as you can see, I have this flexible tool that I can use this different data sets to provide my information. So, but where do these data sets or these data structures come from? Another part of the NFDI for Inc. is a project that Aachen and Darmstadt contributed to, which is called AIMS, and now integrated as the metadata profile service. And there we have designed this kit for the building data set. The metadata profile service allows us to share metadata profiles, to also change them, and to use a modular setup. For example, if you can see our metadata set for the building is also based on the data set for location, and other data sets, for example, the architectural model, are using this building data set and extend it. So the idea is that if this runs for a while, and if you want to create a specialized metadata set for your workflows or for your research data, you can look is there something usable there, and if there is, you can take it. And if you think, okay, I have to add some specialized metadata to one of the sets, or have to change it, I can load one and change it. Or if I don't find anything useful, you can just start from the beginning. And all this semantic information is found in this case in the NFDI for terminology service, where I can search for terms in terminologies that help me to generate these facets and to generate these shackle profiles. So as you can see, this is bound into the infrastructure, and if I use these terminologies that are standardized, and if I use this metadata profile service that the NFDI provides, I can share at the end my information with other people and within the infrastructure of the NFDI for Ing, for example. Okay, this is the part from NFDI for ingest, and now to the next flavor that you can see here. This is the surface of the RDF store that I talked about. This is the development, the UI of the development kit that you can download and use for your own applications. And what you gain here is that you have the possibility to edit metadata. You load again a metadata profile. In this case, you can see we have two here. The building set metadata set and the architectural model metadata set. I can edit, I can view all this stuff, I can search for the stuff. For example, if I search for Köln, you can use a full text search, but you can also use this facets that are automatically generated from the content of all this metadata set. You can see here 3 of them have this license and the other ones the other. And if you can see here, if I use the architectural model set, you have this physical properties like size and height. And from this information here, you can see these sliders beginning with the 150 for the depth of the model or the height of the model, and it goes to 300, which the other model provides here. So as you can see, the search facets are generated from the index, and I can slide to here and see, okay, now it's just one metadata set that fits this set. And the same is true for the map, for example. If I reset this here and look at the heat map, you can see if I zoom in that now only 2 models are selected because only they have this metadata. And if I just change this to a smaller area, you can see only one of these metadata sets now fits this stuff and is therefore selected. And this is kind of an example. The idea is that you generate your own metadata set, and what you gain is the possibility to deal with your metadata in a tool and have a possibility to enter it to a web interface, but we can also search for that via an API or fill in maybe in a Python script data that you have into that system, and now you can curate the metadata that you already have, for example, or whatever you want to do with this data set. And maybe this is an entrance to build something that automates some workflow, for example, that you have a simulation and the simulation produces results, and the metadata from these results are stored in the RDF store and therefore can be changed or viewed or searched or accessed by another script that maybe does another analysis step in your workflow. This is the things we have in mind here. And the idea is that we provide this Docker container. You can download it. You can enter your specialized code, or you add your application profiles and further develop what you want to produce as a tool. And you have the possibility to use all this infrastructure that, for example, NFDI offers in this area, for example, to generate a persistent identifier for that. And this is all based on a modular design, and therefore this component that renders these text fields, these forms, is also separated, and the idea is to produce this with as less dependencies as possible. As you can see here, you have these shackle profile on the left side and the form that is generated from that. And you can also, and if you enter some data, you can also see the output at the end. And this is, if you want to use this, this shackle form, all you have to do is to embed this into your website. This is a little bit of JavaScript code. And the only other thing that you have to provide some kind of backend there you get these information from. And it is also made in a very basic form, so you can use different designs on your website, typical material design, for example, or Bootstrap are provided, can be used to render this form in more detail or around the corners and stuff like that. So you have the possibility to also integrate this into a lot of platforms, and the idea is to make these components as self-dependent as possible, that you can include this into a lot of your applications in the sense of tooling and also in the sense of infrastructure. So that are my contribution to the topic, and now I'm open for questions.
Thank you, Andreas, for your presentation. As you said, yeah, now it's time for questions and a discussion here in Zoom, but it's also time to end the streaming and say goodbye on YouTube.